Hello students, so welcome to my new video. Today we are going to discuss about law of conservation of linear momentum. Okay, I hope all of you know what is linear momentum. Now this is a topic from class 11 from the chapter of Newton's laws of motion, and it is a very important topic because in every exam that you sit there are certain numericals which are solely based on this particular law. Okay, so I hope all of you know what is a linear momentum. Linear momentum is the product of the mass and velocity of a body. Okay, so let's start and see what is actually this law of conservation of linear momentum. Now there are many ways of understanding this law of conservation of linear momentum. Today we are going to understand in a very easy way. Okay, so let us understand this by the help of a simple collision. So two bodies are approaching towards each other and they are colliding. Okay, so we are going to understand this law by this very simple example. Okay, now let us assume that these are the two bodies. Okay, suppose this is one body of mass m1 which is coming in this direction, and this is another body of mass m2 which is coming in this direction. Right? Now since the bodies have a velocity and the bodies have a mass, so the bodies must be having a linear momentum. Okay, so suppose the momentum of this body is p1. You know, linear momentum is a vector quantity, so that's why I have given it vector sign. And suppose the linear momentum of this body is p2. Okay, so these bodies, they are coming and approaching towards each other. Now after some time, what is going to happen? They are going to collide with each other. Okay, so there is going to be collision. So these two bodies are colliding with each other. Now remember students, collision, we are not discussing about collision in this particular video. Collision is also a very important part of class 11, but collision we are going to discuss, that means what happens after collision, what are the changes in velocities that happen after collision or before collision, what are the velocities. We are not discussing about collision in this video. For collision I will be making a separate video for you. In this particular video we are only going to discuss about law of conservation of linear momentum, and we are going to take the example of a very simple collision. So these two bodies are colliding with each other, right? Now when these bodies are going to collide with each other, a force will be exerted on the bodies. Okay, because when the bodies collide with each other, a force will be exerted on the body, fine, on both the bodies. Suppose the force on m1, suppose I am considering as f1, okay, and the force on m2 I am considering to be f2, fine. So these are the forces which are acting on both the bodies, m1 and m2. Now after the forces are acting on both the bodies, suppose there can be many things that can happen. Over here I am considering, suppose the bodies are getting separated. The bodies might not get separated also, that depends what type of collision they are having. As I said earlier also, that collision portion I will be discussing in some other video. Here we are only going to discuss about this law of conservation of linear momentum, fine. Okay, now suppose these two bodies were in contact with each other for a very small amount of time, delta t. Okay, for a very small amount of time, delta t, these two bodies were in contact with each other. Okay, now see what is going to happen. So before the collision took place, P1 was the initial momentum of the body, P2 was the initial momentum of M2. So M1 and M2. So if I say what is the net momentum of the body? Net momentum of the, I can say, system. Now what is a system, you see? What is a system? System means over here these two bodies, these two bodies, that is M1 and M2, I have considered a particular environment or a particular system where only these two bodies are there. Okay, there is no other body around these two bodies, fine, only these two bodies are present. That particular thing is known as a system. Okay, system, this word we will also come across when we will be doing thermodynamics. When I will be making videos about thermodynamics, then also this particular word system plays a very important role. Okay, so this is a particular environment where there are no other bodies surrounding these two bodies. Only these two particular bodies, they are making up a system. Fine. So see, this body was having a momentum of P1, this body was having a momentum of P2. So what is the net momentum of the system? So net momentum of the system is P1 plus P2. Okay, so I have given it with vector sign because I don't know these two bodies are approaching towards each other or they can be going in the same direction also, so it doesn't matter. So that's why I have given vector sign. So the net momentum of the system will be P1 plus P2. Fine? Okay. Now when the bodies are colliding with each other, the total force that is acting on M1, that is F1, fine, and the total force that is acting on M2, that is F2. Now I will be telling just after a few minutes what are these forces F1 and F2. For now, let us first understand that a force is acting on M1, that is F1, and a force is acting on M2, that is F2. Fine? Okay. Now see, Newton's second law says us, okay, what does Newton's second law says? Now from Newton's second law, we can write force is equals to change in momentum divided by time. So this we can say from Newton's second law. So Newton's law says us that if a force acts on a body, then there must be a change in momentum of the body. Okay, suppose a body is there and a force is acting on the body, then there must be a change in momentum of the body. The body's momentum have to change because you see, if force is acting on the body, then there must be a change in momentum of the body. Okay, now over here, on this particular body M1, there is a force which is acting F1. The initial momentum of the body was P1. So the momentum of the body must change. Fine. Suppose if I consider that the change in momentum of this particular body is delta P1. Okay. Delta P1 is the change in momentum of this particular body. And this particular body, the change in momentum is delta P2. Okay, so remember students, these delta P1 and delta P2, these are the changes in momentum of both the bodies. Okay, changes in momentum of both the bodies. Why these changes in momentum is taking place? Because a force is acting on both the bodies. I have considered a force is acting on both the bodies. Now if there is a force acting on both the bodies, there must be a change in momentum of both the bodies. Okay, so suppose the momentum of this body was 5 kg per second, and then suppose the momentum becomes 8 kg per second. Okay, so there is a difference of 3 kg per second. So there is a change in momentum of the body. Okay, so here I can write delta P1 equals to change in momentum of P1. Okay, sorry, of M1, and delta P2 is the change in momentum of M2. So these are the changes in momentum of M1 and M2. Fine. Now see, what was the total momentum of the system? That was P. P was the total momentum of the system, that is P1 plus P2. Now if there is an individual changes in momentum, suppose the momentum of first body also changes and the momentum of the second body also changes, then the total momentum of the system has to change. Okay, I hope all of you can understand. If there is a change in momentum of the first body and if there is a change in momentum of the second body, then the total momentum of the system that has to change. Okay, so let us consider delta P is the total change in momentum of the system. Okay, so delta P is the total change in momentum of the system. Now see, delta P1 is the change in momentum of first body, delta P2 is the change in momentum of the second body, and delta P is the total change in momentum. And in this particular system, only two bodies are present, no other bodies are present. So what I can write from these three? Can I write this one? Delta P will be equals to delta P1 plus delta P2. Yes, of course I can write this one. Why? This is the change in momentum of the first body. This is the change in momentum of the second body. So change in momentum of first body plus change in momentum of second body will give you the total change in momentum of the system. Right? Okay. So let us consider this as equation 2. This is equation 1 and equation 2. Okay. Now see, this particular equation Now see, both the bodies were in contact for a time delta t. Now delta t is going to remain the same for both the bodies because both the bodies were in contact for a particular time delta t. If I divide this equation on both sides, dividing on both sides by delta t, dividing on both sides by delta t, what we are going to get to see. So delta p by delta t is equals to delta p1 by delta t plus delta p2 by delta t. Okay, now either you can write with delta sign or you can also use d. Okay, you know d is much more smaller than delta. So either you can use delta sign. With this one also you can do. With this one fine. This one is not wrong. This is fine. With this one also you can do. But in some other books, this particular thing it is done with d. Okay, so with d also you can do with differentiation. That is delta p delta t. I can write in this way: dp dt equals to dp1 dt plus dp2 dt. So I can also write in this way, right? Okay. Now see, what is dp1 dt? What is dp1 dt? I told you by Newton's second law says us that force is equals to dp dt. Force is equals to dp dt. That is, force is equals to rate of change in momentum. Okay, this is from Newton's second law. We can write force is equals to dp dt. I hope those who know Newton's second law, they will be knowing force is equals to dp dt. That is the rate of change in momentum. dp1 dt. So what I can write? What is dp1 dt? dp1 dt is the rate of change in momentum of the first body. Okay, rate of change in momentum of the first body. So can I replace this one with f1? Yes. Why? Because I said earlier that f1 is the total force which is acting on n1 and f2 is the total force which is acting on n2. So dp1 dt I can replace this one with f1. Okay. dp2 dt I can replace this one with f2. What is f1 and f2? What are the f1 and f2? f1 and f2 are the forces which are acting on first body and second body. So this is your dp dt. Okay. Okay. Now you have to understand certain things. Just few minutes ago I told you that I will be telling you what are these particular forces. Okay, what are these forces? This f1 and f2. What are these forces? Okay. Now see, if I consider that these two objects are part of a system. Okay, when these objects are colliding. Okay, now when at what time these two forces are acting on these two bodies? When the objects are colliding, that time these two forces are acting on these two bodies. I have considered that these two objects or these two bodies makes up a system. That means there are no other bodies around these two bodies. So these two particular bodies, they are making up a system. Right? Now, when two bodies touch each other or when two bodies collide each other, first of all, you have to understand what are the forces that are acting on these two bodies. What are the forces that act on these two bodies? First, when two bodies collide, both the bodies are going to exert a force on each other. Okay, those forces are known as the internal forces. So both the bodies are going to exert a force on each other. Right? Those two forces are known as the internal forces. Right? So here I am considering those two forces are F1 internal and F2 internal. So these two are the internal forces. Now remember, internal forces always act in the opposite direction, because when these two bodies they are going to collide with each other, first of all this body is going to exert a force on this body and this body is going to exert a force on this body. So these two are the internal forces which are acting, okay, on both the bodies, and they always act on the opposite direction. How do we know this one? We know this one by Newton's third law, that every action has an equal and opposite reaction. So if this force is the action, this is the reaction. If you consider this force as the action, then this is the reaction. Now, why these forces are known as the internal forces? Okay, so there many students ask me this question, sir, why these forces are known as the internal forces? Now see, if you consider these two bodies as a part of a system, so you can consider that this entire thing is a single body. Okay, let us consider this entire thing as a single body, since these two bodies are part of a system. Now see, these two forces are acting from inside the system. Okay, these two forces are acting from inside the system. That is why the name internal forces, because they are acting from inside the system. Okay, so that is why these two forces are known as the internal forces. Apart from these internal forces, suppose I have given some external force also. When the bodies were colliding with each other and they were exerting forces on each other, suppose from outside also I have given a certain force to both the bodies. Okay, those two are known as the external forces. So suppose F1 external and F2 external, these are known as the external forces. Okay, these are known as the external forces. Now why the name external forces? Because these two forces I have given on both the bodies from outside the system. These two forces are acting from inside the system and these two forces are acting from outside the system. Okay, so let us consider any one particular body. Suppose this particular body M1. So on this particular body M1, which are the forces that are acting? First of all, a internal force is acting F1 internal. Okay, this force is acting F1 internal, which is exerted by M2. Okay, which is exerted by M2. That is the internal force which is acting on the first body. Also, from outside, I have given this external force, F1 external. Okay, so from outside the system, I have given this F1 external. I have given this force from outside the system. Okay, the sum of this total force, if the internal force and the external force, is basically this particular force. Okay, so this particular force is basically F1 internal plus F1 external. I hope all of you can understand. That particular force I have considered to be F1. Okay, as I said earlier also, what is F1? F1 is the total force which is acting on M1. So what is the total force which is acting on M1? One is the internal force which is given by M2 and another one is the external force which I have given from outside the system on M1. Okay, so the sum of these two will give you the total force which is acting on this particular body M1, right? The same goes for M2. For M2, you see, F2 is the internal force which is acting. F2 is the internal force which is acting on M2, which is given by M1. M1 is also pushing M2. So this is the internal force which is acting on M2, which is exerted by M1. Okay, and from outside also I have given a certain force F2 external. From outside also I have given a force which is F2 external from outside the system. The sum of these two forces is basically F2. So F2 is F1 internal, F2 internal plus F2 external. Okay, so the sum of these two is actually the total force F2. Okay, now, so we can write in this way, F1. So F1 is the total force which is acting on M1. So F1 I can write F1 internal plus F1 external, as I said just now. Okay, so F1 is F1 internal plus F1 external, the internal force which is acting on M1 and the external force which I have given on M1. Also I can write F2 equals to F2 internal plus F2 external. Okay, F2 equals to F2 internal plus F2 external. This is the total force which is acting on the body M2. Okay, now we had this equation. So here I can write dp dt is equals to, so F1 internal plus F1 external. Now see, everywhere I am using vector sign. Okay, if you want to use only the magnitude, that one also you can use, no problem. But if you are using vector sign, everywhere uniformly you have to use the vector sign. Plus F2 internal plus F2 external. Okay, so that is F1 and F2. Fine. Now you see, I am writing both the external forces together. F1 external plus F2 external plus F1 internal plus F2 internal. That is a dPdt. That is a dPdt. Okay. Now, a very important thing you have to understand. I hope all of you know what is Newton's third law. Okay. Now, according to Newton's third law, okay. Now, according to Newton's third law, when two bodies collide, they are going to exert a force on each other which are equal and opposite to each other. So you know Newton's third law that every action has an equal and opposite reaction. So the internal forces that are acting, that both the bodies act on each other, okay, the internal forces which both the bodies give on each other, exert on each other, they must be equal and opposite. Okay, so what I can write from here? I can write F1 internal is equals to minus of F2 internal. Why I have given minus sign? Because I have given it with vector sign, and you know minus sign denotes the opposite direction. So since these two forces are acting in opposite direction, okay, these two forces are acting, one is acting in this direction, F2 internal, another one is acting in this direction, F1 internal. So these two forces are acting in the opposite direction. That is why I have given F1 internal equals to F2 internal. So both these forces are also equal as said in Newton's third law. Now from here we can see F1 internal plus F2 internal will give us 0. Okay, that means remember, if I consider this entire thing to be a system, okay, these two bodies are making up a system, and when these two bodies are colliding, the sum of the internal forces is they are always 0. Okay, where if I consider that these two is a part of one particular system, then remember the internal forces, they are always going to cancel out each other. But if I going to take these two bodies separately, suppose these two bodies I am considering separately, okay, then a force will be acting individually on both the bodies. So force will be acting individually on both the bodies. But once I consider these two bodies to be a part of a system, then I have to understand that these two forces, they are going to cancel out each other. Okay, because you see F1 internal plus F2 internal will give us 0. So from here I can write dP dt equals to, so this particular thing is giving us 0, so I can write F1 external plus F2 external. Okay, so we are left with only the external forces. Okay, now I can replace this one with F external, that is the total external force. So what is F external? F external is the total external force, because you see we are left with only the external forces. Then remember, I had also given an external force on both the bodies M1 and M2. I have given F1 external on M1 and F2 external on M2. So internal forces are cancelling out each other. We are only left with the external force. So the sum of these two external force I can write, that is the total external force that is exerted by me. I have only given the external force, okay, on both the bodies. So that is the total external force that is acting on both the bodies, okay, from outside the system. Okay. So dP dt will give us F Ex. Okay. Now one very special condition, and this is the particular important line of this law of conservation of linear momentum. If I consider from here, if, this word if is very important. If I consider that there are no external forces, okay, if I consider that I have given no external force, suppose the system, these two bodies are coming and colliding, according to them, their colliding force is being exerted, okay, internal forces are acting, but from outside the system, I have not even disturbed the system, okay. From outside the system, I did not disturb any on one of the body, I have not given any force on both the bodies, okay. In that case, I can write if there are no external forces, then I can write if external will be 0. Okay, if external will be 0. Okay, because I have given no external force, so if external will be 0. In that case, I can write dp dt will be 0. Okay, now see, dp dt means ddt of p. dp dt means ddt of p, that is 0. That means dpdt. What is the meaning of dpdt? dpdt is the rate of change in momentum. Change in momentum divided by time. So the change in momentum is 0. Okay. Remember what was p? What was p? P was the total momentum of the system. What was p here? It is written. P is the total momentum of the system. Okay. Now if I say that the change in momentum of the system, okay, after the collision took place, the change in momentum of the system is 0. Change is 0. That means I can write P is constant. That means I can write P is constant. Okay. So this is your law of proof. Okay. There are been proved. So this is your law of conservation of linear momentum. That means if I am not exerting any force from outside the system, okay, there are no external forces which are acting from outside the system, then whatever may happen over here, the change in momentum is not going to take place. Change in momentum is 0. That means the total change in momentum, you have to understand. Individually, there will be change in momentums. Okay, individually the momentum of this body it is going to change from P1 to delta P1. Okay, delta P1 is the change in momentum of the first body. Okay, delta P2 is the change in momentum of the second body. So individually there are changes in momentum. Okay, but if you add, the total momentum before the collision and after the collision, okay, if you add the total momentum of the system, you have to consider, not individually. Total momentum of the system, if you add before the collision in the incident took place, okay, and after the collision, or whatever, you can take other examples also, then the total momentum will remain conserved. This is very similar to law of conservation of energy, we can say. Whenever energy converts from one form to another, we know that if there are no losses of energy, okay, if there are no losses of energy, then always the total mechanical energy, that is the kinetic energy plus potential energy, remains constant. That is the law of conservation of mechanical energy. I hope you know. So that was law of conservation of linear momentum. That means if there are no external forces acting on the system, then the total momentum, remember, the total momentum remains conserved. So here I am writing, if there are no external forces acting on the system, then the total momentum remains constant, okay, or conserved. So two key points over here. If there are no external forces, if there is an external force, then this law will not work. Remember, if you are disturbing the system from outside, then this law is not going to work. Then the total momentum before the incident took place and after the incident took place, they are going to change. But if there are no external forces which are acting on the system, then remember the total momentum, not the individual momentums of the body. Individual momentums of the bodies, they are going to change. But if you add this to momentum, okay, if you add, remember you have to add using vector, because momentum is a vector quantity. Remember this one, you have to add using vector, okay. So the total momentum of the system, that is going to remain constant, okay, or conserved, that is not going to change. Suppose the total momentum of the system over here was 8 kg meter per second, okay. After the incident took place, after the incident took place, now also if you calculate the total momentum, now there will be individual changes in momentum, but if you calculate the total momentum, it will still be 8 kg meter per second. Okay, so the total momentum is not going to change. Remember, you have to add using vectors, since the momentum is a vector quantity. Okay, so that was all for today's video. I hope all of you understood the law of conservation of linear momentum and how to understand it in a very simple way by just taking an example of a collision. Okay, so that was all for today's video. I hope you liked the video. If you liked the video, please like and subscribe. Thank you.